We're going to look at the three forms of a line, and we're going to use this foldable to help us organize that concept. So have the three folds of a line at the bottom of your sheet closest to you. Take the top edge and fold it over so that it meets that line right above where it says three folds of a line. And let's put a nice crease along the top. So now you have what's called a hot dog fold. Take your scissors, go ahead and open up your foldable, turn it upside down, and we're going to cut along these lines only up into the crease. So go ahead and cut along each of those lines just up to the crease like that. And the same thing on the other one. Turn it back over and fold it back the way you originally had it. Okay. So the three forms of a line are slope-intercept form, point-slope form, and standard form. And before we work on the inside, let's go ahead and make sure that we understand what the general form of each of those is. So for slope-intercept form, everybody is pretty familiar with that. That's y equals our slope. We're going to use the letter m for slope, so think of mountain, mx plus b. And b is our y-intercept. Okay, specifically, it's our y-intercept. So slope and intercept. The name tells us exactly what it is that we're looking for. Okay, let's move over to point slope form. So point slope form is a little different. We're going to have y minus, and it's going to be subtracting a point, which I will do that one in orange, y1, and that equals our slope times x minus x1. Okay, so here, our point is given right here with x1 and y1, and again, our slope is given right there. So the name of the form tells us exactly what it is that we can find within that form. The last one we're going to look at is standard form. Standard form is fairly boring. There's not a whole lot going on with it, not a whole lot you can do with it. But it's of the form a x plus b y equals c. Okay, not a whole lot there. So a, b, and c are constants, are numbers. Okay, so let's open these up and let's see what we can do with each one of these. So let's look at the slope-intercept form. So we actually have two questions here. So the first one is asking us, what is the equation of a line with a slope of -2/5 and a y-intercept of the point 0, 3? So the first thing that we note is our slope. We have a slope of -2/5, and we have a y-intercept, and we're going to use b for y-intercept, and our y-intercept is 3. So if we think of our general form, where we have y equals mx plus b, we can simply substitute in -2/5 for m and substitute in 3 for b. So I have y is equal to -2/5 x plus 3. So that's the equation of a line with a slope of negative 2/5 and a y-intercept of 3. Now we have a different question here. This time we're asked to graph. It's not asking for the actual line, although we are going to write it just so that you can make the connection and it might help you see things a little better. So they tell us that we're going to graph a line with a slope of 2. So here I know that my slope is 2, and then I have a y-intercept of this time is negative 3. So I know that my y-intercept is negative 3. So then that would give me the equation of a line of y equals 2x minus 3. Okay. Whenever we're graphing a line, we want to start at the y-intercept and then work at the slope. So right here, this is where we're going to start. So we're going to start at the y-intercept. So our y-intercept is negative 3. That's the point 0, negative 3, which is what they gave us right here. So the slope is 2. That means I'm going to go up 2 and right 1. So let's do that. I'm going to go up 2 and right 1. Up 2, right 1. I'm going to do a few of these because I want to make sure I draw an accurate line. And then I can go the opposite way, down 2, left 1, down 2, left 1. So this should all be review. And then I can go ahead, line up my ruler, and draw on a nice line. Notice how my line takes up the entire space of the graph. So when would I use slope-intercept form? I would use it when given the slope and the y-intercept. And I want you to remember that y-intercept is that point where x is 0 and y is some number. X has to be 0 for it to be the y-intercept. Okay, let's go on to point-slope form. Close that one up, and let's look at the next one. So here we have a line passing through a point, negative 5, 2, with a slope of 2/3. So I know I have a point and I know I have a slope. So I'm going to label my point. This is my x value and this is my y value. I'm going to go ahead and label that so I don't get confused. And I know that my slope is 2/3. It gives me that right here. Okay. So the equation of a line, it doesn't ask me for a specific form, so I'm going to go ahead and just simply be lazy about it and use point-slope form and leave it in point-slope form. So point-slope form is y minus y1 equals m times x minus x1. So the only thing that we're substituting is the variables here with the little subscript underneath. So that means I'm going to have y minus, well, what's y1? It's going to be 2, so I'm going to put 2 right there, equals my slope, which is 2/3, times x minus x1. I have to be careful about this because this minus is not this minus. They're different minuses. So now I have a minus minus. I'm just going to clean it up. I don't need that parentheses anymore. So y minus 2 is equal to 2/3 x plus 5. The outer parentheses I have to keep. So that's the equation of the line in point-slope form. It didn't ask me to put it in the slope-intercept form. I might ask you to put it into slope-intercept form later, but for right now, that's the way we're going to leave it. So then the next section that we have is what is the equation of a line that passes through the points -2, -3, and -8, -5. So here I'm given points, I'm not given a slope. So whenever I have that situation, I have to find the slope first. So my slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay, so I'm just going to go ahead and substitute in my values. So you want to be very careful. This is going to be my y's. So I'm going to start with my y's first. So I'm going to say that's -5 minus, that's a -3. Okay, so I have to be careful with those minuses. And then my x's are right here. I have to go in the same order. Since I started with this y, I have to start with that x. So that's -8 minus, again, I have a -2. So I have a minus. That means my slope is -5 plus 3 divided by -8 plus 2. So when I clean that up, that's going to give me -2 over -6, and that simplifies to 1/3. So now I have a slope and I have a choice of points. Notice I said choice. So we're actually going to do this twice. You don't have to do it twice on a test. You just have to pick one and go with it. So here I'm going to have my slope is 1/3, and I'm going to pick the point -2, -3. In the other column, I'll have my slope as 1/3, but I'll pick the point -8, -5. They'll actually be the same line, and I'll have you show me that later. So that means this is going to be y minus y1, which right now is -3, is equal to my slope times x minus -2. So if I clean that up, y plus 3 is equal to 1/3 x plus 2. And I can leave it like that because it just says what is the equation of the line. It doesn't tell me what form to put it in. So let's go ahead and look at this one. So that's going to be y minus my y1 is -5 is equal to 1/3 times x minus -8. I'm just trying to got to move that a little bit. Wrote too big. Okay. So now if I clean it up, that's y plus 5 is equal to 1/3 x plus 8. And again, this is really the same line. It's just because I have it going through two separate points. So when would you use point slope form? When you're given the slope and a point or when you're given 2 points. That's when you would use point slope form. Okay, the last one, standard form. So let's look at that. So standard form, the question is, what are the x-intercept and y-intercept of this linear equation right here? Well, we cannot just simply look at that and pull any information out from here. I'm actually going to create 2 columns. I'm going to have one column for my x-intercept and the other column for my y-intercept. And before I go anywhere, what I want to do is I want you to get in the habit of thinking like this. When I'm looking for my x-intercept, that's going to be a point. My x is what I'm looking for, and my y is 0. Okay? When I'm looking for my x-intercept, my y is what I'm looking for, and my x is 0. So notice, x-intercept x, y-intercept y. That will help you to remember what is what. Now we simply need to substitute in 0 for anywhere we see a y. So that means we have negative 2x plus 3 times 0 equals 15. This becomes 0. So that's negative 2x equals 15. I need to divide by negative 2 to get x by itself. So that gives me x is equal to negative 15 halves. So I'm not going to put that into a decimal. I am going to write it, though, as a coordinate. That was my x, and my y is 0. I'm going to do the same thing for y. Here my x is 0, so this is negative 2 times 0 plus 3y equals 15. That's a 0. So now I have 3y is equal to 15. I'm going to divide each side by 3. So that gives me y is equal to 5. So that means I have the point 0, 5. That is my y-intercept. So the question I ask you is, can you easily tell what the slope of the line is using standard form? And the answer is no. So how do you find the slope of a line given it in standard form? Well, you have to put it into slope intercept form. And that's the form y equals mx plus b. So this is the same equation that we just did, and we're going to solve for y. I'm going to rewrite this. Negative 2x plus 3y equals 15. So how do I solve for y? Well, I want to get y by itself. Y is right there. I want to leave it there. So I'm going to turn negative 2x into a 0, which means I add 2x to both sides of my equal sign. So that gives me 3y is equal to 2x plus 15. Now I want y to be by itself, so I'm going to divide that 3 out. I'm going to divide all terms by 3, not just the ones I like. So that leaves me with y is equal to 2/3 x plus 5. So this equation and this equation are the same line. So when would you use standard form? Well, it's helpful just to keep it in the standard form when you're solving for your x-intercept or your y-intercept. It's really not very useful for anything else. So that completes your trifold of the 3 forms of a line.